Ladies and gents, I know y'all have been working really hard, especially in math. I also know that some of you need a little bit of time to catch up on things that you've fallen behind on. So this week is going to look slightly different, slightly, not terribly. Today we are going to review the quadratic formula, which we started last week, and add one more small layer in there that may help you speed up the process of using the quadratic formula to solve. But then on Thursday, all I'm going to give you is, I think it's, let's see, 6 questions, 1, 2, 3, 4, 5, 6, 7, 7 questions, an online guided assessment on Agile Mind. That's it. No videos to watch. 7 questions. That's it. So hopefully between the small video today, there will be a small assignment to submit today as well. And just the 7 question guided assessment on Thursday. Hopefully that gives you a little bit more time to relax. Hopefully the weather's good and you can enjoy it. And for those of you that need to do some catch up, hopefully you have time to do that as well. Keep in mind, we are, let's see, today is, or when you're watching this, is Tuesday the 28th. We only have 1, 2, 3 more weeks left. That's it. 3 more weeks of e-learning, 3 more weeks of school. So finish strong. So here we go. We are going to start on page 309 in your workbook. If you want to load Agile Mind online, again, my course is on the top. Unit 8 on the left side, down arrow next to topic 22, down arrow next to lessons. And we're going to go all the way to the very last lesson, lesson number 11. Again, it's page 309 in your book. So while you open your book, I'm going to flip my camera around. Whoops, I don't think I pre-opened my other camera. Here we go. You may also want a calculator open up. I am going to open up maybe, come on. Sometimes the touchscreen doesn't like me all that much. There we go. I'm going to open up my calculator just so I have it. So starting on page 309. On page 309, underneath the opener, you notice 3 quadratic equations, 3 graphs, and 3 uses of the quadratic formula. Remember that any quadratic equation, well, let's start with a quick review. Why is it quadratic? To be quadratic, we know that the equation has to have a highest exponent of 2. If we notice, in every single one of these equations, we do have that highest exponent of 2. Now, these equations happen to not be in our transformation form. They do not happen to be in what we call vertex form, with the A, H, and K. I know that because they don't have any parentheses in them, and they have this B term in it, this X term. This is actually what we call standard form of a quadratic. Think about when we did lines, we had slope-intercept form, we had point-slope form, and we had standard form for a line. For quadratics, we have both vertex form, that form we used for finding transformations, and we have what we call standard form. Eventually, if we don't get to it this year, you will, I promise, 100% do cover this by the time you hit Algebra 2, but we should talk about how do I get from one form to the next, because you can do that. But there are reasons each form is important. Obviously, vertex form helps us identify transformations, and this standard form helps us solve equations, especially when we have to identify A, B, and C for the quadratic formula. So I feel like I went off on a slight tangent. Here's our goal with this, what's happening right here. We want to compare what is happening in the graph for each quadratic equation to how many solutions we got from the quadratic formula and see if we can notice something. So when I look, this quadratic formula for the first equation gave us 2 solutions, -3 and 2. The second equation gave us, well, it looks like 2 solutions. It gave us 1 twice. So this is only 1 unique solution. 1 unique solution. Remember, unique means you're the only one of a kind. There's only 1 unique solution. This is 2 solutions. And in this very last example, we got no solutions. Now, you may be thinking, why no solutions? We'll take a look at what is happening underneath this square root. Underneath that square root is a -7. And if you try and type that in your calculator, which I will go ahead and do, second square root button, -7. you're going to get something that says error. There's a non-real answer. We know that we cannot take the square root of a negative number. So it gave us no answer, because if I can't do this math, how can I finish? So then the question was, again, can we compare this to the graph? Well, we know that solutions have multiple names. Solutions are the same as x-intercepts, which are also called zeros. So let's take a look. We found these in solution form. Let's go back and look at the x-intercepts. Well, there's an x-intercept, and that x-intercept has the point -3, 0. There's an x-intercept, and it has the coordinates 2, 0. X-intercepts visually, I get the same number as solutions when I solve, and that other title, zeros, which I know you can't see on the bottom of my notes here, the reason it's also called zeros is because I always have a 0 in my point as my y. I got 2 solutions. I have 2 x-intercepts. I got 1 unique solution here, and if I look, I have 1 unique x-intercept, and it is at the point 1, 0. My x-intercept is the same as my 1 unique solution. And last but not least, if I look at this graph, I have no x-intercepts. And when I look at my solutions from solving using the quadratic formula, I got no real solutions. Okay, so is there a way we can speed this up? Is there a way we can speed up solving? The answer is yes. Most quadratic equations, will fall in this category of having 2 solutions. Some will have 1 and some will have none. Well, is there a way we can predict how many you're going to have before we finish this whole quadratic formula? Because we know this whole quadratic formula can take a little bit of time to set up and evaluate. Well, the answer is yes. So I'm going to flip the page to number 310, or to page 310, and you will notice at the top of page 310, the quadratic formula is written up there for you. So we saw on the previous page, the reason that last group, that last equation had 0 x-intercepts and 0 solutions is because we couldn't take the square root of -7. We couldn't take the square root of -7. So it actually boils down to what happens under the square root. My pen will work here. I want everyone to take their pencil or pen, and I want you to just circle everything under the square root. Notice I didn't include the square root. This piece of our whole quadratic formula is what we call the discriminant. This is the piece, discriminant. This is the piece that determines for me, am I even going to be able to square root? Because if I find out that my discriminant, this stuff underneath the square root, is a negative number, I can't finish my equation. So what's the point in setting it up? I know I'm going to get no solutions. So we could always start our quadratic formula with just evaluating the discriminant, and then we can determine, is it even worth it to continue? So jumping to number 2, I'm going to start like the quadratic formula like we started on Friday. I'm going to start by identifying my a, b, and c. Now, a is what's in front of x squared, so that's 2. B is what's in front of x, so that's 4. And c is our constant, the number that stands alone, so that's 7. So rather than starting by plugging into everything, I'm going to start with just the discriminant. I'm only going to plug in there. I'm going to find out, am I even going to be able to square root this number? So here we go. Our b is 4 squared minus 4. Our a is 2. And our c is 7. And I'm going to go to my calculator, and I'm going to type that in exactly as I see on my paper, parentheses and all. So going to my calculator, I'm going to quit this. Here we go. 4 squared minus 4 times 2 times 7. Notice, again, my calculator looks exactly like my book, parentheses and all, and I get -40. Okay, so let's think about this. Underneath that square root, we got -40. Are you going to be able to type in your calculator the square root of -40? Go ahead and try it. Pause the video if you want to. And you should find out you can't square root a negative. You can't square root a negative. And this, if I compare it to that first page, the opener, square rooting a negative is what happened in that last example. And because I can't do that, I can't get any solutions. And because solutions and x-intercepts are the same thing, my graph is going to have no x-intercepts. So flipping back to page 310, if I have a negative discriminant, I am going to make the conclusion I have no solutions because I cannot square root a negative. No solutions because I cannot square root a negative. So let's try the second one. This one, not even worth finishing because again, I can't square root a negative. I know I'm going to get no answers. So here we go. Second one, we'll start by identifying A, B, and C. A, coefficient of x squared. I don't see something, but remember, as long as x squared is there, that means there's a 1 in front. B is what's in front of x, so that's 4. And C is the constant, the number that stands alone, which also happens to be 4. So going to the discriminant first, B is 4 squared minus 4. A is 1. C is 4. I'm going to go to my calculator and parentheses and all. I'm going to type it all in. Whoops. I don't want that squared to be inside the parentheses. That squared, as we wrote it on our paper, is outside the parentheses. Whoops. I'm not doing too good typing into my calculator. There we go. Now it looks like everything that is on our paper. I'm going to hit enter, and I got 0. Okay, so you may be thinking, can we square root 0? Well, you know what? I'm going to just go ahead and double check. Square root of 0 is 0. It worked. It didn't say error. It didn't say non-real answer. As long as it doesn't tell you error, it works. So what happened when we got a square root of 0 in the opener? Well, flipping back to that, if I look, the one that has a square root of 0 is this middle example. And that middle example, when we got a square root of 0, only gave us one unique solution. We still got solutions. We had one x-intercept, but it was only one unique solution. So let's find out why. Because we were able to square root, that means that, yes, we need to go ahead and finish solving this using the quadratic formula. So we're going to go back to what we did not do. We did not do the x equals. I'll switch to a different pen since we finished the discriminant part. X equals opposite of b. Our b is 4. The opposite is negative 4. Plus or minus the square root of our discriminant. Well, our discriminant was 0. So I'm going to put a 0 underneath the square root. All over, make sure that fraction symbol goes all the way back to the equal sign. 2 times our a, and our a was 1. Look at how much nicer that quadratic formula already looks because we did the discriminant first. It looks so much easier. So let's go ahead and simplify. We know that the square root of 0 is 0. And 2 times 1 is 2. At this point, we also remember from last week that we can't add and subtract at the same time. So here's where we really split this into two different little equations. One where we do negative 4 plus 0 and then divide by 2. And the other one where we do negative 4 minus 0 and then divide by 2. Negative 4 plus 0, well, adding 0 does nothing. I might as well cross it out. Adding 0 does nothing. So negative 4 divided by 2 is negative 2. There's my first solution. And subtracting 0, again, really, that does nothing. So I'm going to cross it out. And hey, look, the reason that a discriminant of 0 gives us only one unique solution is because adding 0 and subtracting 0 does nothing. I get an answer, but because that adding and subtracting of 0 does nothing, that answer is always going to be the same. Okay, we're going to do one more example, and I just added this to my book, so you can go ahead and feel free. You got some space on the bottom. You can feel free to write that down. And I want you to identify A, B, and C. I want you to pause the video, identify your A, B, and C. Okay, so I have an A of 1 because there's a 1 in front of x squared. B is negative 5. C is negative 6. And rather than solve this completely by the quadratic formula, setting up the whole thing, first I am going to go to the discriminant, which is b squared minus 4ac. Now I want you to type that into your calculator and find out what you get for the discriminant. Go ahead and pause the video to do so. And I'm not going to show my calculator on this one because I've already found out that I get a discriminant of 49. So now I'm going to ask myself, can I square root 49? And if you want to go ahead and type that into your calculator to verify, then please, please, please feel free. I find out that yes, I can square root 49. And because I can square root 49, I'm going to finish the formula. So finishing the quadratic formula, I got x equals the opposite of b. Now this is important. Our b is -5. The reason I say opposite, not negative b in the quadratic formula is because if it's already negative, I want the opposite. I want a positive. Plus or minus the square root of my discriminant. And our discriminant was 49 all over 2 times a, which was 1. Again, doesn't that look so much nicer than what you had to go through on Friday? Now we're going to simplify. The square root of 49 is 7, and 2 times 1 is 2. Now I have to split this into 2 different problems because I can't add and subtract at the same time. So we have 5 plus 7 divided by 2, and we have 5 minus 7 divided by 2. Now, as you simplify this in your calculator, remember to hit enter after you add. 5 plus 7 is 12. Divided by 2 is 6. There's one solution. 5 minus 7 is -2. And -2 divided by 2 is -1. In this case, we got 2 solutions because we had a positive discriminant. So what's the purpose of this discriminant? Really, the discriminant is here to make your life easier. Notice in that first example, we didn't need to do the whole quadratic formula just to find out that we were going to get no answers. And in the second and third example, look at how much nicer our paper looks compared to what we were doing last week on Friday. The discriminant truly speeds up that quadratic formula process. So this is something to really keep in mind, and I'm going to put it on the Unit 8 cheat sheet on Canvas, is understanding what happens when you get a positive discriminant. Well, let's take a look. In our first example, we got a negative discriminant. Second example, we got 0. 0 is not considered positive or negative. Third, we got 49. So I'm going to make a little bit of note. This is example 3. When we got a positive discriminant, our quadratic equation has 2 solutions. Sorry if you hear my kids in the back. When we got a 0 discriminant, so again, negative, example 2 had a 0. Example 2, which I guess that is really B up there. When we had a discriminant of 0, we got, it looks visually like we got 2 answers, but notice how they're the same. We got 1 unique solution. Do I really need that word unique? Probably not, but I like it because it helps us realize that even though we visually see 2, because they're the same, it's only 1 unique solution. I guess that doesn't need to be plural. And if the discriminant is negative, that would be example number 1, which is really A that we did. We get no solutions. Okay, so just thinking about this whole thing one more time, another summary is on the top of page 311. This is a really good math journal right here. You have the quadratic formula, you have the part identified that is the discriminant. So things to think about. When b squared minus 4ac, so when the discriminant is greater than 0, aka when the discriminant is positive, what does that tell you about the number of real solutions you will get from the equation? Well, glancing back at page 310, if the discriminant is positive, I know I'm going to get 2 solutions. Sketch a possible graph for the situation showing the number of x-intercepts. Remember, x-intercepts are the same thing as solutions. So I don't have a specific equation here, so I just need to draw any parabola that has 2 solutions or 2 x-intercepts. So I'm just going to draw mine here and put some arrows at the end, and notice there's 1 x-intercept, there's 2. That is a graph of a parabola that shows me I have 2. Could it open upward? Yeah. Could it be over on the right side of the x-axis? Yeah. Could it be straight down the middle? Absolutely, as long as it has 2 x-intercepts. when b squared minus 4ac, or our discriminant, is equal to 0. When it is equal to 0, what does that tell you about the number of solutions? We get one unique solution. So now we are going to sketch a graph of any parabola that only has one solution, which means it only has one x-intercept. So here we go. Could open upward, could open downward. Now keep in mind, in order to only have one x-intercept, you're just going to kind of bounce off that x-axis, if you will. And last but not least, when our discriminant is less than 0, in other words, when it is negative, because it is less than 0, that is when we get no solutions. That is when we don't need to finish the quadratic formula, no solutions. So we're going to draw one more graph here, and this time you need to draw a graph where I never touch the x-axis. Now, be really, really careful. Let's see if I have a pencil. I'll draw a non-example too. I am going to draw a graph like this that will never touch the x-axis. Doesn't touch x-axis. Doesn't touch x-axis. So I'm going to draw one more graph on here, and you guys tell me what you think. Will this graph, does this satisfy having a negative discriminant, having no solutions, meaning no x-intercepts? The answer here is no. This one, even though you don't see it crossing the x-axis, this one right here does cross the x-axis, because remember what those arrows mean. It means your graph is going to keep going. Even if you didn't draw your arrows, keep in mind they're still there. That graph is going to keep going. So this one does not work. I will make sure I write that on there if you look at the PDF on Canvas, because I'm going to, of course, take a picture and post what I wrote in my book. But this one does not satisfy no solutions. This one would actually have two solutions, like up here, because that parabola is going to continue in the upward direction. So this does not work. So again, point of discriminant, really to speed up your life when it comes to using the quadratic formula. And again, hopefully just make your life a little bit easier. So your job for today is on page 311, which we ended at. You are going to solve using the quadratic formula 2a, b, and c. Now, I highly, highly, highly encourage you to start with the discriminant, because if you find out that the discriminant is negative, you're done. No solutions. You don't need to use the entire quadratic formula. So practice what we learned. Page 311 today, you're going to submit that. And remember, on Thursday, it's going to be a little bit easier of a day, so you can relax or play catch up, whatever you need to do. So page 311 today, and it'll be a guided assessment. Don't worry, I'll post a reminder for you, and that will be on. Have a good one, you guys.